As an engineer, you already know that much of your job when guiding your clients goes beyond the technical. For instance, system owners have to build public approval, obtain the necessary environmental permits, and navigate the regulatory and political landscape, all while designing an efficient water treatment and delivery system. That's why your leadership is critical. You alone can keep them on track. The system built today must be able to handle the unknown challenges of tomorrow. You must be the one to lay the path into the future for these municipalities, because we all know once the project is underway, there are many decisions that distract from the overall goal. Let's look at that. In the beginning of a project, your long-term goals are crystal clear. The strategic goals and the tactical considerations all work together. But for many water system owners, they don't work together for long. As the project develops, the layers of decisions become more numerous, and one critical shift begins to happen. Instead of asking, will this decision support our goal? The question becomes, how much does this cost? Sound familiar? Well, it can lead to a vicious cycle. Let's say that corrosion has caused increased maintenance and that has led to a rate increase. The higher utility bills have led to more public scrutiny. Public scrutiny, in turn, does make funding more difficult, and now you have a much smaller budget to work with on the new project. That smaller budget shifts the focus to immediate costs instead of long-term cost savings. Cheaper options are chosen to manage the smaller budget. Often these cheaper options include metallic pipe materials. And now, that metallic material guarantees that the problem that started this project, corrosion, will now be built into the new system. The irony is that money now must be budgeted for protecting the pipe and preparing for the inevitable. This is not what's meant by starting with the end in mind. Well, time passes, the soil chemistry has changed, the water chemistry has become a bit more acidic. Stray currents are interfering with the cathodic protection system. And before you know it, the corrosion process has sped up and the system lifespan has decreased. Once again, the rising cost of energy and the increases in maintenance and operational costs lead to yet another rate increase. And sure enough, increased costs lead to public scrutiny, all during the years leading up to the bond referendum, the one that will dictate the budget for the next system improvements. The sad truth of the matter is that you cannot accomplish your fiscal sustainability goals nor your environmental sustainability goals inside of this vicious cycle. Why? Because the question, how much does this cost, is actually going to become, how much will this cost you as the designer of the systems of tomorrow?